Yo, what up, Sci Fam? It's your boy Nickel, and today we're going to learn about seasons. And we're going to discuss and uncover why seasons happen. So, to begin with, let's review this idea that the Earth orbits around the Sun, and when it does, it goes in an ecliptic type of pattern. So, if we were able to go above the orbit and look down on the Sun, and the Earth, as it orbits around the Sun, it would orbit in an elliptical type of path. So it's almost like a squished circle. So what that means then is that the Earth is at one point closer to the Sun than it is at another point in the orbit. So let's uncover that a little bit down here in our diagram. So go ahead and draw yourself sunshine and an orbital plane that's ecliptic with the Earth in two of these positions. Now, if we had a long enough tape measure, we could measure in between these. Luckily, someone else has done this for us. But when the Earth is closest to the Sun, and maybe I should even just exaggerate it a little bit and move the Sun a little bit more over here. When the Earth is the closest to the Sun in our orbit around the Sun in 1 year, we're 91.4 million miles away. And as the Earth then continues to orbit around, it gets to this further position from the Sun, and at that position, we are then 95.5 million miles away from the Sun. So these are important characteristics of our orbit. And a lot of times people believe that because we get closer and further from the Sun, we have seasons, but this is not why we have seasons. You see, if we actually looked at when the Earth was at this position that was 91.4 million miles away, this actually happens on January 3rd. When the Earth is the furthest away from the Sun, this happens on July the 3rd. So the Earth is orbiting around the Sun, and it looks like it's actually furthest away from the Sun when in the northern hemisphere here we experience our summer. But the Earth is further from the Sun. When the Earth is closest to the Sun on January 3rd, in the northern hemisphere, we experience winter. So there's another part of the equation here that is all of the importance, carries all of the importance, and that is the fact that our Earth is tilted. So if we were to include that tilt of our Earth here, which is 23.4 degrees, if we were to apply it over here as well on the July 3rd position at 23.4 degrees of tilt, we could look at the northern and southern hemisphere in a different way. So if I were to draw the equator of the Earth, it would look something like this. And if I were to have a position that was position A and a position B, position A and position B over here, you can see that in July, position A is actually tilted closer to the Sun. And over here on January the 3rd, position B is tilted so that the southern hemisphere is kind of pushed towards the Sun. Here, the northern hemisphere is pushed towards the Sun. So if you've ever tried to start a fire with a magnifying glass before, you know that the smaller the area that you concentrate the Sun's light in, the more energy there is. If the Sun's energy is spread out over more area when you're trying to catch something on fire with a magnifying glass, it doesn't work as well because all of that energy is dissipated. So what we find then is if we're tilted closer to the Sun, then we end up experiencing warmer temperatures. So let's take a look at these two different times in our orbit around the Sun. So let's first start with the January position. So on January the 3rd, our orbital position, if you're at point A, which is in the northern hemisphere, it's actually going to be the Earth is tilted away from the Sun. Okay, here in the January 3rd position, position A is tilted away from the Sun. So if I were to exaggerate that 23.4 degree tilt, and if this were the equator, this is A, this is B. A is tilted away from the Sun, B is tilted toward the Sun. So the southern hemisphere at position B, southern hemisphere is tilted toward the Sun. Well, the opposite is true at the July 3rd position. So if we were to look at the July 3rd position, when it is over here, the tilt's still that same 23.4 degree tilt. And if I were to draw, and it's the sun's here, if I were to draw the northern hemisphere and the southern hemisphere at the July 3rd orbital position, now the northern hemisphere, is tilted toward the sun. And the B position, the southern hemisphere, is tilted away from the sun. So that means that the sun's energy is not as direct. All right, so let's take a look here at what that looks like if you're actually on planet Earth. Well, if you are tilted toward the sun, it's different obviously in your daytime than if you're tilted away from the sun. Now, as we know, as northern hemisphere human beings, earthlings, that in July, the northern hemisphere, if we're tilted toward the sun, July is our summertime. And if we're at position A in the northern hemisphere, we know that January is actually our winter time. So we're tilted away from the sun. So we can use that information down here. When we're tilted toward the sun, and it's the middle of summer, we know that the days are long, and that's because the sun rises in the east, and it rises high into the sky. Because this position of our Earth is tilted toward the sun is going to appear as though it reaches a higher point in our sky. And since the sun is up for longer, it can send more of its infrared radiation down to heat up our Earth more and more, which helps increase the temperatures of our Earth. When we're tilted away from the sun rises in the east, but since we're tilted away from the sun's highest position doesn't get as high as it does in our summertime sky. Then the sun sets in the west. So there's less time for that solar energy to heat up the Earth, and those solar rays are less direct. So let's summarize then. When we're tilted toward the sun, this is when we're going to have long days of summer. And we have warm temps. So with warm temps. And when we're tilted away from the sun, we have the short days of winter with cool temps. So our seasons, summer and winter, have everything to do with how our Earth is tilted, whether it's toward the sun or is it tilted away from the sun. And as our Earth goes around that orbit, the tilt is going to change from being away from the sun to toward the sun, and vice versa. So when we go from summer and the sun starts to not go as high in the sky, we call that in-between season our fall or our autumn. And as the Earth goes around the orbit and it reaches that position where we're tilted away from the sun the most, that's when we're in our winter time. And then when that tilt changes from being away from the sun back to going toward the sun, this is when spring happens. And once it's actually in that position where we're tilted toward the sun, that's when summer happens. And this is why, if you are thinking about the northern and southern hemisphere and you're on Earth, if there's a tilt to the Earth, and if we look at the equator, if you're in the northern hemisphere and you're tilted away from the sun over here, this is going to be your winter. At the same time, if you're in the southern hemisphere, that's going to be your summer. And this is why people that live in the southern hemisphere experience an opposite season as the people that live in the northern hemisphere. It has everything to do with the tilt of our Earth. And now you know. I'll catch you on the next video. Peace.